Also focus key in this chapter is easy because physical chemistry NCRT line by line is not so important. What is really important is example. Example can be asked in the exact same way. Okay, so that's why here example is more important. So as we are doing chemical kinetic, it is about the speed of reaction. Is reaction speed slow, medium, or fast? Example, in some of the reaction, it is the rapid or fast reaction. Example, there are three type of reaction: fast, uh, slow, and medium. But what is more important is these are the three type of reaction, correct? So fast reaction is mostly ionic reaction because ionic reaction in water are really quick. Okay, so this fast reaction occur in case of the ionic reaction. Example, if you take silver nitrate, AgNO3, it react with the NaCl. What should be the product? AgCl plus NaNO3, correct? So you can see that this AgCl will settle down and this reaction is extremely fast. So many ionic reaction will be the fast reaction. Come to the slow reaction. Example, rusting of iron is very slow. It takes years usually. Rusting of iron only in presence of the moisture, correct, and air. So this process is very slow, take years, and there are many. Most of the reaction are the medium, not too fast, not too slow. Example, inversion of cane sugar. Karthikya, what is cane sugar?
Sucrose,
Very good, sucrose. Marinder, what is the meaning of inversion of cane sugar?
close to glucose,
And
fructose,
so if you see, sucrose is dextrorotatory. If you see, glucose is positive and fructose is negative. Fructose is overall more. This is more. So overall, you will see glucose and fructose overall product are negative and reactant is positive. So there is an inversion of configuration, which convert from the positive to the negative. Inversion of configuration. Okay. Whenever there is a reaction, and example, your A convert into B. Here A is reactant and B is product. And you want to write rate, speed. With that time, your reactant will reduce and product will form. Because reactant is reducing, then you will have negative sign. Delta A by change in time. Okay. And I will write this in the bracket. Why bracket? Because bracket will show that it is the concentration. So, Chandra, what is the meaning of bracket?
the concentration.
Concentration. Okay. Or molarity. In the chapter of ionic equilibrium, same bracket is used for the active mass. Okay. And product will form because product amount keep on increasing with the time. So you will say ki product amount is increasing. So this thing. Okay. So reactant will disappear and your product will appear. This appear and reactant disappear because question will be asked rate of appearance and disappearance. Jordan, what will be the unit of rate of reaction? Jordan, are you there?
So yes, so milliliter per second. No, it should be moles per liter per second.
How do we know? Because rate is the concentration divided by time. Concentration or molarity unit is mole per liter, and time is second, so it will be mole per liter per second. Yes. If you take gas, in case of gases, if you calculate the rate, then rate unit will be atmospheric because instead of the concentration, you are using pressure, and pressure is explained in the atmosphere per second. Any doubt, guys? If you do the same stuff for any reaction that occur instantly, very rapidly, to be honest, everything will be same. If you calculate rate, it will be written in the form dA by dt and plus dB by dt. So sometime question can be asked you what is the difference between the first situation and second situation. First situation is average of the full reaction, and second situation is instantaneous at a given moment. Second situation is for the given situation. Example, we are expanding further. If N2 react with 3H2 and form 2NH3, Sarah, how should I write rate of the reaction? Sarah.
N2 and H2 in bracket.
So whatever will be your coefficient, it will be in denominator. In case of N2 coefficient is 1, so you will write 1 by 1 minus sign because it is showing it is reactant. So it will be delta N2 concentration divided by delta T.
So minus sign because reactant is reducing, right?
Yes, reactant is reducing, that's why minus. As I mentioned, ki your coefficient should be in denominator, that's why 1 by 3. Everything else will be same. D H2 concentration divided by dt. And you know product is increasing, so it will be 1 by 2 plus delta NH3 by dt. So what is
Sir,
happening in this case? Yes, Pratigya.
equal क्यों use करते हैं?
Because overall rate of the reaction remains same because all the things are happening simultaneously.
लेकिन स्टोइकियोमेट्री अलग अलग है.
हाँ, स्टोक्योमेट्री अलग है तो उसके हिसाब से रेट भी तो मतलब सेम तो है, बट ओवरऑल coefficient is making difference in this case. Then you are dividing the same rate by 3. Whatever was the value of the hydrogen, then you are dividing by 3 to make it equal.
ओके सर.
Understood?
हाँ सर.
Hmm. Next is a rate law. This rate law is also known as rate equation or rate expression. Thing is same, to be honest, it's very easy to understand, and we'll discuss question from a rate law or rate equation or rate expression. What does it say? Ki if you have your any example A for A and B for B forming C for C, and D for D. This is any reaction where you have reactant and product. If you want to calculate rate, speed of the reaction, it depends on the number of the reactant molecule, A and B. Here it is A, here it will be B. Okay, is this correct? Any doubt, Tohina? Anybody have doubt in this?
Sir, it not always right, sir.
Hmm.
So the small a won't always be like it's not always the coefficient, right?
So this is wrong.
So it's not wrong. Some cases it can be, some cases it won't be. Is where is something that I've read somewhere.
Okay. What everybody says. Is this correct or wrong?
Like it, in some cases, like it may or may not be equal to the stoichiometric coefficients.
Yes. So that's why we are using different number X and Y. So we don't know what is the X and Y value. All these things is explained experimentally, proved experimentally. So you can't tell merely by looking at the reaction what will be the order of reaction. Correct? So if you remove proportionality constant, you will get rate constant. A raised to power X and B raised to power Y. So we are saying it may or may not be equal to the A or B. May or may not. We don't know. It could be same, it could be different. Okay. May or may not same, and it will be explained based on the reaction. It will be explained based on the reaction. Example, if you take this reaction, 2NO react with the O2 and form NO2. So what will happen in this situation? If you calculate rate law, then it will depend upon NO square. By the way, whatever is your coefficient, it will come into the power. Same like equilibrium. And oxygen, because coefficient is 1, that's why power will be also 1. But we can't tell. It will be explained by the table. So we want to understand table how it happened. This is same example given in NCRT. I will make sure I will cover each and every question of NCRT, at least example. Okay. So example, if you have a table, you have initial concentration of NO, concentration of oxygen, and rate, and NO2 formation. Okay. So if you look at the number, you take this 0.3, this 0.3, and here it is 0.96. This was a rate, and NO2 formation rate, because rate in every situation remains same. Jordan, actually you have doubt in this table, correct?
Yes, sir.
0.384. So make the same table. Okay. So this is the table given to you. And based on this equation, you have to tell how to calculate the order of the reaction. By the way, simplest way to calculate the order is the simple addition. But okay, so I will introduce this word also, order of the reaction. So order of reaction will be simply equal to all the coefficient, but practically, experimentally. You can't tell based on the example. In this case, if you calculate order of the reaction, then instead of x you have 2, instead of y you have 1, so order of this reaction will be 3. Okay, so it will be proven experimentally. How? If you look at this equation, you have to compare. First step, you have to compare two vertical value. Second step, keep one value constant and see what is the impact of the change in the value. Example, if this is double, what is the impact on this? Because oxygen is same. If you increase NO concentration by double from zero point 0.3 to zero point 0.6, what is the impact of this? It increased 4 times. Okay, it increased 4 times. So anything when you make it double and another value increase 4 times, can you say rate will directly depend upon the its power square? Any doubt, guys? Jordan,
No, sir.
whatever
Or
is the value, you are taking power because if you are making it double, it is 4 times. It means raised to power 2. If you want to understand how oxygen change, keep and no constant. Example in equation 1, 2, 3, and 4. Equation 1 and 3 have the same value, correct? So this is constant. But here it is becoming double. Here it is becoming double. If it is double, what is the impact between first and third equation? Double. If one thing is double and you made another thing is also double, what would you say about this? The rate directly depend upon this. Jordan, any doubt?
no, sir.
If you combine both of this, you can say a rate that depend upon NO raised to power 2 and oxygen raised to power 1. So first step, keep one value constant. Second step, see when one thing is changing, what is the impact on the another thing? If it is double, what is the impact on this? 4 times raised to power 2. Keep another value constant, 0.3, 0.3. If you make it double, then it will also become double. So directly proportional. Correct, done. That's how you compare. Any doubt, guys?
No doubt. So
Hmm. So merely looking at the equation, you can never tell what is the order of the reaction. Example, if you see chloroform and this chloroform react with the chlorine, it will form CCl4 and HCl. Pratigya, what will be
यार
the order
मुझे
of the reaction?
कंफ्यूज हो गई उससे वो टेबल से
You are confused.
ऐसा
Table say,
हाँ सर
tell
मतलब
me.
ये समझ में आया कि डबल होने से वो भी डबल होगा रेट भी डबल होगा वो जो शुरू से बोले ना पहले डबल सेम तो
नहीं,
4 गुना होगा वो फिर से बताइए
you have to compare the data. Compare equation first and second. In first and second, your oxygen amount is exactly same, but your NO amount is becoming double because data is saying from zero point 0.3 to zero point 0.6. If you compare equation 1 and 2, and here your final rate is 4 times. If you compare these two numbers, 2 is 4 times of 1. So you can see when NO is becoming double, then your rate is becoming 4 times. It means it depends upon the raised to power 2. Any doubt, Pratigya?
So it is experimental value ना.
हाँ, एक्सपेरिमेंटल वैल्यू,
Yes,
ये डेटा ही
true.
तो दिया ना, एक्सपेरिमेंटली प्रूवन है,
मतलब यही सही है.
यही सही है. गॉट इट.
Okay.
If you see, look at this reaction. What will be the order of reaction? You can
2,
never tell. You can
3,
never tell.
3.
It should be 2 logically. But actually, if you see order here, it will be 1.5. Okay, it will be 1.5. Same way, if you take this equation CS3, CO, C2H5, when it react with the water in axis of water, what will happen? This is CH3COOH plus C2H5OH. Okay. If you see rate is equal to K CH3 COO C2H5. Barinder, what will be the order of reaction? Barinder, what will be the order of reaction?
ऑर्डर ऑफ रिएक्शन के लिए मतलब इक्वेशन बैलेंस करना पड़ेगा.
हम्म, बैलेंस तो है.
So 1,
You can never tell. You can never tell based on this data, but in reality, it depends only on this. Here it will be 0. So order will be 1 because this is pseudo first order reaction. But based on this data, you can't tell. Why I am writing all those equations given in NCR? Examiner can ask you direct question based on this. Okay. So this is how we calculate the rate. Example. If you compare order of any reaction, the interesting part is this order can be 0, it could be fraction, it could be even any integer like 1, 2, 3, 4, 5. So anything is possible in case of order. We will come up with one more word, molecularity. Molecularity can be positive only and no fraction is possible. That we'll see in the later stage. Chandana, if you look at this equation, rate is equal to K A raised to power 1 by 2 and B raised to power 3 by 2. What will be the order? And Jordan, your question is if you take rate equal to K A 3 by 2 and B minus 1.
So then
Jordan.
we just have to add 3 by 2 plus minus 1. That
Hmm.
will give us the order.
Hmm. 1.5 and minus 1.
Yes, so 1
Half.
by 2.
Chandana.
This is not.
Okay. 2. 1 by 2 plus 3 by 2. Done. Okay. Sarah, how is it going for you because you are doing it for very first time?
okay, sir.
You are able to understand?
Yeah, sir.
Okay. See, if you are reading like properly first time, it will take some time to grasp. So let me know. So accordingly, I will make sure you understand everything. Okay. So, Tuhina, what do you mean by elementary reaction?
Sir, elementary reaction is like, how do you say, it's only one step that's occurring.
Yes. So elementary reaction is one step reaction. Reaction occur only in one step. Pratigya, what is the complex reaction?
बहुत सारे स्टेप होगा.
Hmm? Sequence of elementary reaction. It means two or more than two. Sequence
More
of
than
elementary, either two or more than two, will be known as the complex reaction. Again, if you see unit for different type of reaction, so how to calculate unit of the rate constant? Marinder, unit of rate constant.
So
Marinder,
mole per second.
it depends which order we are talking about. What is rate constant? We are talking about K. And you know, if your n number of A convert into product, then your rate will be equal to K A raised to power n. Correct? And you are calculating K value. So it will be rate A raised to power n. Okay? A raised to power n. So if this is the situation, you know what is the value, what is the unit of rate? Mole per liter, correct? Mole per liter per second. Yes or no? Mole per liter per second. Yes or no? So in this case, you will see key unit will be your mole per liter raised to power 1 minus n, and it will be always minus 1. I will show you, then you will understand better. Example, if you take first zero order reaction, Chandana is there?
no, so
No. So if you calculate for zero order reaction, what is the unit of K? Rate unit is mole per liter per second, and here in the denominator you have zero, so it will be same, mole per liter per second. Jordan, what will be the unit of first order of reaction?
So unit will be K is equal to liters only.
Mole
Moles,
per
sorry, moles per liter.
1 minus 1
1 minus 1
per second.
seconds. Seconds only. Yes, sir.
Same formula you can apply here only in the zero order. K is equal to mole per liter. 1 minus 0 will be 1 per second. Sarah, in second order reaction, what will be K unit?
Moles per liter 1 minus 2
So
per second.
what will be the overall value?
Raised to minus 1.
Because power become minus 1.
Yes, sir.
So in a third order reaction,
Um, Sir, it's supposed to be 1 minus n, right? So mole to the power of minus 2, liter to the power of 2, and second inverse.
Any doubt?
No doubt.
If you know this, then Pratigya, if you take K value is equal to 2.3 into 10 raised to power minus 5 liter per mole per second. So what will be the order of reaction? And Barinder, for you, if K value is equal to 3 into 10 raised to power minus
Second
4,
order.
then, yes, Pratigya, what is the
Second
order of the
order.
reaction? Second order. How do
Second.
you know it is changing like this? Mole liter per second.
Yes.
Barinder, what is the unit in this reaction? And remember, we are bothered about the unit, not the number. Unit matter. Same here, unit matter. Barinder, what will be the order
So
of reaction?
first order.
First order. Correct.
Sir,
Because, yes, Chandana.
sir, what you did after the table question order?
Hmm. After table, we did some example. What order can be zero, fraction, and integer. Elementary reaction is one-step reaction. Order of a reaction is simple addition of the stoichiometry in rate law. Complex reaction, sequence of reaction. Unit of rate constant depend upon the situation. For zero order, first order, second order, or third order, based on the unit, we can tell the rate constant unit. Okay. And now we wrote last two examples. Based on the unit, how you can tell what will be the this order of the reaction. Okay. Any doubts, Sandana?
No, sir.
Sir.
So we are doing the last topic. I wanted to do more, but to be
Sir.
honest, I am also tired. हाँ हाँ Pratik.
रोज वो मतलब इक्वेशन से ऑर्डर फाइंड करना वो पीछे बताएंगे
कौन सा?
इक्वेशन से ऑर्डर
Which order?
मतलब इक्वेशन दिया होगा
हाँ.
फाइंड ऑर्डर
If
मतलब कुछ
equation
और एग्जांपल
is given in your question, you can't tell order of the reaction based on the equation. You can't tell. But if rate law expression is given, like this, you can tell. How? Example in this, you have to add the power. Here it is 1 by 2. Here it is 3 by 2. So 1 by 2 half, 3 by 2 1 and a half. 1 and a half plus half 2. That is what you were asking, Pratigya.
सर ओके ओके इन द टेबल
Which table? This one.
जो नाइट्रोजन वाला आप लिए थे
Nitrogen.
जो एन हाँ वही वाला वो सिर्फ और थोड़ा ऊपर 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 हाँ वही सर ये जो टेबल ओनली दिस इक्वेशन के लिए ना सभी इक्वेशन के लिए
Nee. See this. If in question you have this table, it means this is the experimental value. This table value is the experimental value. So through this table, you can calculate order of the reaction. Okay. So based on
हाँ
the
सर
table, you can
लेकिन ये
calculate
टेबल
question. हाँ.
टेबल सिर्फ मतलब वही रिएक्शन के लिए है ना?
हाँ, फॉर ए गिवन रिएक्शन यू विल हैव ए पर्टिकुलर टेबल, मतलब इस रिएक्शन के लिए ही टेबल ये होगा, अदरवाइज फॉर एवरी अदर रिएक्शन यू विल हैव डिफरेंट टेबल।
ओके।
अंडरस्टूड?
हाँ सर।
So guys, let's do last topic of the chapter, molecularity. Who is missing? Jordan Rowland. Sarah, you were trying to say something?
No, sir, my mic was on.
Okay. So next is the molecularity of the reaction. And this molecularity is important for the theoretical question. Molecularity. So if you see the molecularity, this definition is really important. And you have to compare with the order. Example, if you see the molecularity, it is how many uh, chemical are reacting in the elementary reaction. So remember this molecularity for the elementary reaction. Sandana, what is elementary reaction?
This is two-step reaction.
One step reaction. This is the one step reaction. Okay. This is the one step reaction. Second, here reacting species collide with each other. Reacting species collide simultaneously.
So for
Yes.
complex reactions, we can't say molecularity.
No, we can't.
Okay, we can't like if we break it down into multiple steps. Also, we can't just say it for one of the steps like that.
For one of the step we can calculate,
Hmm.
but for the overall we can't.
Okay.
Yes. Okay. Example, if you see, like molecularity can be different. It could be one, two, three. So molecularity having the value three is very rare and very slow process. So usually it is one or two. It it is usually one or two, not more than three. With with three, it is rare. With three, it is very, very, very rare. Okay. So usually you will see ki, like molecularity is one or two, three is extremely rare. Okay, example. If you look at this reaction, KClO3 react with 6FeSO4 plus 3H2SO4. KCl with 3Fe2SO4 for thrice plus 3H2O. Okay, so based on this, here here you have one coefficient 6, 9. So what should be the molecularity according to this? 10. Okay. According to this, molecularity should be 10. But here we can't tell. If you see the order of this reaction, it is only 2. So this is based on the complex reaction. Reaction happen in many steps. Reaction happen in many steps, and that's why uh, here order will be decided by the slowest step. You will, based on this reaction, you can never tell what is the order of the reaction, what is the molecularity of reaction. Logically, it should be 10, but it is not. Why? We said even with 3 number, it is rare. And how it could be 10? Practically not possible. It means mostly one or two molecule collide at a time, not like thousands of molecule. Correct? Normally, at a time, one or two molecule interact with each other, not multiple type of molecule. Example. Remember, whatever example I am giving, all are the NCRT examples, so we don't miss any. And you should be aware about each and every example. If you see this reaction happen in presence of iodine, and your medium is alkaline. And what will be the product? 2H2O plus O2. Balance. If you guess, like if you have a random guess, Jordan, how should I write the rate equation?
Minus 1 by 2 H2O2
Hmm.
is equal to 1 by, oh yeah, TH2O2 divided by
Delta or equal to, yeah. K.
KH2O2.
Imagine. In this case, if you see order of the reaction, it will be two. One H2O2 molecule and one iodine molecule. Okay. So order of the reaction will be 2. So that is interesting. Your order of the reaction is 2. Got it? Any doubt? How do we know? We don't know. It's just because it is given in the NCRT. Examiner will never ask you this question. Ki tell the order of this reaction. No, never. But yes, based on the reaction, it can be asked. Example for the same reaction. For the same reaction, if it is given in the two part, one H2O2 iodine, it will react with water and form IO negative, and then H2O2 react with IO negative will form H2O plus iodine negative plus O2. Okay. So based on this reaction, you can say the molecularity of both these step is 2. In both the situation, if you calculate what is the molecularity, Sarah, what is the molecularity in this case?
The two,
And what is the definition of molecularity?
uh, sir, it's for elementary reaction.
Yes, for one reaction. And it will be given in the equation ki this is RDS. Chandana, what is RDS? Rate determining step. slow step. So usually slow step is the rate determining step. And in this rate determining step, if you want to calculate what is the order, you have to always see a rate determining step. In this situation, you know in your slow step, H2O2 molecule is 1 and iodine molecule is 1. That's why your order will be 2. Understood? Your order of the reaction will be 2. So if you calculate order will be H2O2 1 and iodine will be 1. 2. Understood, guys? Any doubt? So based on that, you can calculate what are the difference between the order and molecularity. So Hina, what is the difference between order and molecularity? So Hina, what is the difference between order and molecularity?
She was not.
She is not there. Pratigya,
Yes.
other difference. Order can be 0, it can't be 0. Correct?
The order can change with temperature and pressure, whereas molecularity cannot.
That how, not order. We'll talk about the rate constant change with the temperature. Rate constant.
Okay, sir.
It can be fractional value, can't have fractional value. Only integer 1, 2, 3, 4 like this. Okay. Then it is for both elementary reaction, you can calculate order and complex reaction. Elementary reaction and complex reaction have order. But molecularity is applicable only for the elementary reaction. No use in case of complex reaction. Correct? Then here it is explained by the slowest step if you have complex reaction. This same for slowest step or fast step. No, no, not same. Same will be the wrong word. Applicable for both. Not only just slow step, even at fast step. Applicable for both. Tell me guys, any doubt? Any doubt?
No, sir.
No, sir.
Hmm. So this is what we'll do today. I wanted to finish zero order, first order, half lifetime, and this pseudo first order. But I am tired, and I think still we have covered almost 50% of the portion. Pratigya, Brinder, Chandana, Jordan, Sara, and T.
Sorry, sir, there was a network issue.
It's okay, Tuhina. We will solve question, guys.
Sorry,
Hmm.
where did you finish?
Molecularity and this
Order.
order difference. Yeah,
Okay, sir.
that is what we'll do for today. Chemical kinetic, chemistry, chemical kinetic. Half lifetime we didn't do this. Rate constant for half lifetime we didn't do this. Uh, how to do this? First, come keep one value constant. Example here, B is constant. Check how it is changing. You know it is getting double, 2x. This is also double, 2x. What does it mean? Can I say rate directly depend on a raised to power 1? Same, directly depend. Any doubt, guys? And
No,
when a is same and this is getting double, this become 4 times. So with respect to b, it will be raised to power 2. Any doubt, guys? Ask your doubt. So with respect to a, it is first order. With respect to b, it is second order. 1 and 2. Do you have option 1 and 2? Yes. Any doubt? Any doubt, guys?
No, sir.
See how how long it is given. Do you think you can do all this stuff?
no, sir.
No.
Not required. Mm, activation energy, float. Every time I see most of the question, na, it is given from the end of the chapter, not from the beginning. I don't know why. This is the rate. Pratigya, if when the initial concentration of A is tripled, keeping B constant, initial rate would be your current reaction is like this. Rate K, A raise and B concentration. Now in new value, K remains same. Your A become triple and B is constant. What is the 3 square? 9 K A square B. Can we say it will be 9 time of the R? Any doubt, guys?
No,
Yes. Do you have question?
no,
Anybody? If you don't, then next turn is Barinder. Hmm, hmm. This from this. Rate of appearance of B is given by this. Correct relation between the average appearance of B with the average disappearance of A is given by Barinder. Any doubt? Virendra, any doubt? Direct. Whatever is your coefficient, it will come in denominator. 2 coefficient in denominator. Now you have to calculate only this part, delta B by delta T. How to calculate? This 2 will go to another side. Multiply, done. Chandana,
Sir, option D.
yes. You have to tell first order. This is second order reaction. This is 1 second order reaction. This is a half and 2 order reaction. This is minus 1/2 and this it will be 1. Simple addition of power. Jordan,
Yes, sir. 1 minute. One minute, sir. Just solve it.
I will ask one more question from the Sarah and Tuhina, then we'll end the session.
So, option B.
It is A and C that is given in the relation as of now. So
Ah,
for A, it will be minus 1/4
yes, sir.
delta A by dt is equal to, for C, it will be 1/6 dC by dt. Any doubt?
No, sir.
So what will be your rate of reaction? Because rate will fix. Example C value is given. So 1/6. What is delta C by delta T? 6 into 10 raised to power minus 2. 6 cancel, it will be 10 raised to power minus 2. Correct?
Yes, sir.
Now what will be the rate value with reference to B? Minus 1 by
My
3
yes, -1/3, sir.
delta B by delta T. Correct? Rate value is minus 2. 3 will come to multiply. Done. Any doubt?
Sir,
No, sir.
30
Check.
into 10 power minus 2.
Yeah, because time is also given, 10 seconds. You multiply by 10 time.
Yes.
Then you calculate what is the amount consumed. It's like this is equal to delta B by delta T, correct? Delta T value is 10. This will also go to another side.
Yes, sir. Understood.
One question for Sir Arrhenius plot. Date order of this. Not this. Sarah, we we did the same question. Like we wrote same equation in our notes. Sarah, is this D? Minus 1 by 1 dN2 by dt is equal to 1 by 3 dH2 by dt plus 1 by 2 dNS3 by dt. Any doubt, guys? Sarah,
No, sir.
Tuhina.
Yes, sir.
Last question for you. Hmm. Correct difference between the first order and second order reaction is.
One second, sir.
Hmm.
Hmm. Sir is the option C.
Though B we haven't studied now, but in the first order, your rate will directly depend upon the reactant concentration of 1. And in second, it rate will be like reactant concentration is for 2, correct? So first order does not depend upon the reactant concentration, wrong.
Yes, sir. That I said. How is it the second option? I want to know.
First order reaction can be catalyzed, yes. Second order cannot be catalyzed, it doesn't not make sense. Any reaction can be catalyzed.
Okay.
First order reaction does depend upon the reactant, correct? Second order does not depend, it also depends.
Yes, sir. But the
B
half-life of...
option will do once we'll start with the half-life of the first
Okay, sir.
order does not depend upon, it does not depend upon the amount of this. Why? Because your value will be 0.693 by K.
By K, yeah.
That's why.
Yes, sir. Yes, sir.
So guys, what do you say? How is this chapter, Sarah? Because maybe you were not confident about this.
I'm tired, sir.
Same here, man. I am also tired, but it's important to do thing when even you are tired because it reminds us ki it is mandatory. We don't have choice. Even you are tired, you supposed to read. Not always, just to make sure ki you are pushing yourself to the new limit. Sarah, Anthony,
Okay, sir. Okay, chapter.
okay, not tough.
A little bit.
Little bit because it's in the beginning stage.
Yeah, sir.
Tuhina Prabhu,
Easy, sir.
Jordan, Roland,
It's a good chapter, so just need to revise.
Chandana,
Yes, sir, I understood everything.
then Barinder Kaur, Barinder
Yes,
Kaur,
sir.
understood everything.
Yes, sir.
And last, Pratigya Sharma. Pratigya, are you there?